All right, so this one you're going to do concavity on. So for concavity, we need the second derivative. So we're going to do the first derivative for this one is 3x squared plus 6x. And then we can go right to the second derivative, so we have 6x plus 6. So for concavity, we're looking for, again, we're looking for our critical number, and then we're looking for is it positive or negative on either side of that to determine if it's opening up or opening down. So for this one, first thing I have to do is find my critical number. So I'm just going to set it equal to 0. So x equals -1 is my critical number. Now, you can do your tests multiple different ways. So what concavity tells you is, or what the critical number tells you is it switches at that point. So you could set it less than or equal to 0 or less than 0 and greater than 0 and solve them out to figure it out. Or you could just pick a number and see if it comes out to be positive or negative. Sometimes picking a number is easier. This one, picking a number is a piece of cake. So let's just pick a number. So I know at -1, so let's do -2. So if I did 6 times -2 plus 6, I get -12 plus 6. So I get -6. So when x is less than -1, it's negative. So it's concave down. I think I wrote my answer sheet in interval form just because I was literally doing interval form for all my calculus book that I'm writing. We're trying to be consistent and doing everything in interval form. So I don't care how you write it. You can write it that way. That's fine. And then since it's a linear and it's going to switch, since it's linear and it's a space, this is a linear equation, we know it's going to be positive on the other side. So if x is greater than -1, it's positive. So it's concave. And that's it. That's what you'd do for that one. If it wasn't linear, you might want to actually go through and do it just to make sure, because it could actually be like an intersection point and actually both be negative on both sides. That is a possibility. But since it's linear, you know it's going to switch at that point because it's a straight line. But you could always just plug a number in. You can plug in 0 and you get 6, and it's positive. So, all right. Any questions with that one? No questions? We got that one? Yes.
So I know I'm forgetting something. It's negative 2,
Huh?
It's -2 for.
I was plugging -2 in for the x in the second derivative.
Yes.
Yeah, just to figure out if that was going to, if that second derivative was going to be positive or negative.
Okay.
But any random number.
Any random number would work, yeah, as long as it's within that range. So like -1 was my break point. That was the critical number. So I just pick a number on either side of it.
Okay.
To test it.
Okay, so I'm now.
Yeah. If you had more than one critical number, you'd have to test each section. So if you had 2 critical numbers, you'd have 3 sections to test to see what happens in those 3 sections.
If the answer comes out negative, you know it's going down. If it's positive,
Positive, you know what's going on.
Okay.
Yep. And you also can use that to figure out if it's going to be a min or a max too. So like if it's concave down, you know it's going to be the values in that section are going to be maximums because it's a peak. If it's concave up, you know it's going to be a minimum because it's a valley. So you can use, that's what the second derivative test actually goes through and looks at. I'll switch back in 1 second. I just got to copy this problem. That's number 2. So when we that one's that one. All right. So this one will be concavity 2. All right, so the first thing you want to look at, so like this one was one of those ones like you could instantly just go right into the quotient rule if you want. However, it's always nice to look at it and see if you could factor things out first. This one you actually can simplify, which does make your life a lot easier. So if I took an x out of the top, I have 1 minus x. And if I factored the bottom, I have, what is it? Or x minus 1 and x minus 2. Now these two right here, if I look at this one, those kind of look the same, just a sign error. So we can flip the sign around. So I can change this to negative x, and then that would be x minus 1 over x minus 1, x minus 2. So I get negative x over x minus 2. So now doing the derivative on that is a lot easier than doing the derivative on the first one. So f of x is negative x, so f prime of x is negative 1. G of x is x minus 2, g prime of x is just 1. So y prime equals negative 1 times x minus 2 minus 1 times negative x over x minus 2 squared. So I've got negative x plus 2 plus x so I got 2 over x minus 2 squared. So that's the first derivative. Since we're looking for concavity, we just need the second derivative. So we're going to take that. And find the second derivative. I'll give everybody a chance to finish writing that down if you didn't.
So,
yeah.
I know we're not talking about mins and max limits, but
so if you were looking at this one, your critical number would be 2. That'd be the only critical number you'd have, because it makes the bottom 0. So, and actually in this one, if I remember right, there was no min or max.
Yeah, so since y of prime is greater than 0 on all x's, there is no limit. Yeah,
so if you plugged in 2 to it, so if you plugged in either direction, the bottom's always going to be positive, and the top's always positive. So you're never going to get a negative number out of it. So it never switches direction. So, because remember, the whole point of the critical numbers is it's got to be increasing to it and decreasing from it, or decreasing to it and increasing after it. So it's got to change. If it doesn't change, it's not going to have a min or a max. This one, your 2 is actually a vertical asymptote. So there is no actual change there. Which is why I'm not asking for your mins and maxes on this one. All right, so find our second derivative. Same concept. So my f of x is 2, so f prime of x is 0. G of x is x minus 2 squared. So g prime of x. This one I have to technically do the chain rule, but the inside of it comes out to be 1 when I do the derivative of it. So it's just 2x minus 2. So I've got 0 times x minus 2 squared minus 2 times 2x minus 2 over x minus 2 to the 4th power. So if we simplify this one down, I have negative 4 x minus 2 over x minus 2 to the 4th. So my second derivative is negative 4 over x minus 2 to the 3rd power. So my critical number is still 2 in this case. Now, unlike the mins and maxes, this one has x to the 3rd or to the 3rd power down below, so that can change sign. It's not a square. So we will have concavity up and concavity down. All right, so, and actually, I actually take that back a little bit. It doesn't matter if it's positive, or I mean, it doesn't matter if it changes direction in concavity. You can actually have both sides be concave up or both sides be concave down. It doesn't necessarily have to change direction, unlike mins and maxes where it does have to change direction. Yes?
Could you explain how you got 2 again?
Oh, it's just setting the bottom equal to 0.
Oh, gotcha.
Because there's no x on the top, so I don't have to worry about the top. If there was an x on the top, I'd have to worry about the top too.
Yep, sorry.
That's fine. So critical numbers are always setting the numerator and the denominator to 0. So it's where zeros happen.
On both.
So yeah, so it's either if it happens on top, that's going to give you a point where it's crossing the x-axis and a 0. If it happens on bottom, it's going to give you a vertical asymptote or a hole or something like that. So those are the numbers that are going to change. My graph's changing somewhere there. So, all right. So I've got my critical number of 2. So now again, I basically have to pick a number on either side of it and see what happens. So let's pick 3 and 1. Or actually, no, 3 and 0, because I always like using zeros. So if x equals 0, I have negative 4 over negative 2 to the 3rd power. So I get negative 4 over negative 8, which is 1/2. So when x is less than 2, it's positive. So it's concave up. If x equals 3, I get negative 4 over 1, which is negative 4. So if x is greater than 2, it's negative, and it's concave down. And remember, you can always, for these problems, just throw them into Desmos and see what the graph looks like. It's like, that verifies it for you. It's like you can look, and this one actually, it literally is one of those, like, cross on both sides. So it's pretty, once you see it, it's like, oh yeah, that you can verify your answer. So it's like, if you do the graph and your answer is wrong, then you can go back and look and figure out what you did wrong. So that's one of the nice things about this stuff, is that the graph really does show you if you're right or wrong. All right. Any questions, other questions with this one before I do the next one?
How did you simplify the bottom part to get from the fourth power to the third?
There's an x, so I pulled out so the 0 times x minus 2 squared is gone in the first part. So that's 0. And then this one's negative 4 times x minus 2. So I took that x minus 2 and one of those. Make sense? Okay. That's why, like, the first time, if you might have had a tendency to go, oh, let me do negative 4 times x, negative 4 times negative 2, and then you wouldn't have noticed that you could have canceled it out. What would have happened at that point is when you plugged in 2, you would have ended up with 0 over 0. And at that point, like, in terms of your critical numbers, it still wouldn't have mattered. You still would have gotten the same answer and everything else. But whenever you get 0 over 0, you know you could factor something out. So it's like then, in certain situations, that is going to cause a problem. Not necessarily in this problem. But.
And when you set the denominator to 0 for the critical number, you don't ever include the exponent?
It wouldn't matter. It depends on what the problem is. Like, since this one's a parenthesis with the exponent doesn't make a difference because really what's inside matters. So like if I put x minus 2 to the third power equals 0, I would do the cubed root of both sides, and the cubed root of 0 is 0. So it kind of cancels itself out, so you don't have to worry about it. So that's one of those things, like when you're looking at it, you have to figure out what piece matters to do. Like if it was x to the third minus 5, I would need the third on the x because that does matter. In this case, it doesn't really make a difference, so I don't necessarily need it. Good questions, though, because a lot of that, this is like the stuff that, like remembering how to do things and why to do things. All right. This one, there's a hard way to do it. Scott found out. And there's an easy way to do it. So this one we're going to do mins and maxes. We're not going to do the concavity. So we're looking for mins and maxes on this one. You'll notice I'm doing the ones for concavity that are easy to do the second derivative, and the mins and maxes are the ones that are more complicated to do the second derivatives. So on purpose. So whenever you have just something outside of a parenthesis like this, it's actually easier to distribute it and just use the power rule than to do the product rule. You could still get the exact same answer, and actually, depending on how you simplify it down, you will get the exact same thing. But it's always nice to distribute and not have to worry about that. The power rule is definitely the easiest way to go with these things. So we're just going to quickly change this to x to the 1/3. So my problem now becomes x to the 4/3 minus 4x to the 1/3. And now I'm going to do the derivative of both pieces. So I have 4/3 x to the 1/3 minus 4/3 x to the negative 2/3. Any questions to that? Now, the way this is written, it's going to be very difficult for you to find critical numbers. Okay, so what you want to do is you want to try to simplify this problem down. You want to get rid of your negative exponents, and you want to make it into some kind of a fraction so that it's easy to work with. So that's really where a lot of this problem comes into. Unfortunately, this test is a lot more algebra heavy than the actual calculus part because it's really simplifying things down sometimes. So for this one, I'm going to change this to a fraction. So this becomes 4x to the 1/3 over 3 minus 3x to the 2/3. I'm going to change them to fractions first. And now I want to get a common denominator. So I want to put it all together. So this way I can set the numerator equal to 0 and the denominator equal to 0 and find my common denominators. or find my critical numbers, I should say. So my common denominator is going to be 3x to the 2/3. So I multiplied this part by x to the 2/3, and I multiplied that one just by 1, because the denominator is there. So I get 4x minus 4. Questions before I go on? I wanted a common denominator, so my common denominator is 3x to the 2/3. I already have an x down the bottom here. I mean, not an x. I already have 3 down here. So the only thing I needed to multiply it by was that. And this one, the second one, I already had everything, so I didn't need to multiply by anything. So, and 1/3 plus 2/3 is 1. So that's why the exponent is gone. All right. So that's linear critical numbers. So I have 4x minus 4 equals 0. So x equals 1. And then 3x to the 2/3 equals 0. So x equals 0. All right, so now when we're looking at this, we want to, again, figure out where is it positive, where is it negative. So that's what we're looking for in my my derivative. So I needed to switch from a negative to positive past that number. So let's look at each of the numbers. Now, if we look at this, can the denominator ever, so this is actually one of the biggest things to look at, especially when you have a fraction. If you don't have a fraction, it doesn't matter, the top is what you're looking at. But if you have a fraction, we're going to have 2 possible things that we're going to look at. All right? If you have negative over negative or positive over positive, it's always positive. It's only when it's 2 different signs, one positive, one negative, that it's going to be negative. So if you can eliminate having to deal with one of them, it makes your life a lot easier. In this problem, can the denominator ever be negative? You have an x squared there, right? So, because if you look at that piece right there, so this right here is the same thing as saying 3, the cubed root of x squared. That's what that fraction is. So, can that there ever be negative? No, because anytime you put, whatever number you put in there for x, right? It's going to be squared, which is going to get rid of your sign. So that'll never be negative. So I know my denominator is always positive. So now the only thing I have to look at is my numerator. So if my numerator is positive, the whole thing is positive. If my numerator is negative, the whole thing is negative. So we've got 2 critical numbers here. So that means I got to try 3 numbers if I want to do that. So if I have a number, let's say less than 1, so let's do 0. So if x equals 0, so 4x minus, or not 4x, 4 times 0 minus 4 is negative 4. So it's negative on that side. Oh, actually, I shouldn't have tried 0 because there was the 0's there. So hold on, I can't use 0. I have to use a half. So 4 times 1/2 minus 4 is negative 2, so it's still negative. If we try a number on the other side, so let's try 2. 4 times 2 minus 4 is 4, so it's positive on that one. So if it's negative to the point and then positive after it, what is it? It's going down to the point and then up after the point. That's a minimum. So that's a minimum. Now I know it's negative on that side because I already did the 1/2. So if I did -1, let's see what happens on that one. So 4 times -1 minus 4 is -8. And it stays negative on that one. So this is none. It's not a min or max. So this value right there is my only point that matters. What do you mean by it's because it's a squared thing? Yeah, so I only have to look at the top because I know that's positive. But if you put a number, if you put whatever number right
Why is it negative on both sides?
on this one,
Because it's squared, right?
no, because when I plugged the number in, they both came out to be negative. So like when on this side I plugged in 1/2, it came out to be -2. On this side I plugged in -1, it came out to be negative. Yeah, we still have to worry about the top. The reason I didn't even deal with the bottom is because it was squared. So I knew the bottom was going to be positive, so the top is the only thing that changed. Oh yeah.
So because there's because there's 2 critical numbers, you've got to try 3 different ways.
Yep. You got to check each section.
Makes sense.
So, but the nice thing is when you're checking, like when we did the 1/2, we technically we could use it for both. So it's like this way you didn't have to necessarily do it twice. So it's like if you were doing, not that any of you are going to remember this probably, back when you were taught to do inequalities, if you're doing quadratic inequalities, you had 3 sections because it was crossed at 0. So you had to break your points and test each section to determine if it was going to be positive or negative and where to shade. So.
So you test the one that's negative, or
I'm testing the sections. So in essence, here's my number line. I have 0 and 1. I want to know what's happening in each of these sections. So over here, I tested 2 and it was positive. Here I tested 1/2 and it was negative. Here I tested -1 and it was negative.
but for the fraction, so obviously the bottom part is positive, so you don't test that. You test
Right.
the top.
So I'm only testing the 4x minus 4. I'm only doing the 4x minus 4.
So you test it.
Yeah, test it if it's positive or negative.
So you could have tested the bottom instead of the top.
No, because the bottom was always going to be positive. So you're technically testing the whole thing. So like, you could have plugged those numbers into the 3x to the 2/3 power and got an answer. It just had been messy. But since your goal isn't to find out what the value is. Your goal is to find out if it's positive or negative.
But yeah, because it is squared. It's
Right. Since the bottom's always going to be positive, why waste your time and do a whole bunch of extra work when you don't need the actual number? I just need to know a sign. So, and that's really the key with this and that's what the key with a lot of this stuff is when you're doing it is figuring out when you need to do that extra work and when you don't. Like one of the questions you guys had before is when should I simplify, when shouldn't I? So it depends on what you need to use it for. D is we have to simplify these down a little more because I need to use them. And it makes it easier to use them if they're in simplified form. So, yeah. No, just tell me if that critical number gives you a minimum or maximum. If you did, you just take the 1 and plug it back into the original problem.
And if you get negative and negative or positive and positive.
It doesn't switch, so it's not a minimum or maximum. So in this case, that 0 actually ends up telling it's the switch between concavity. So. Huh? The 0, if you did the second derivative, 0 ends up being concavity, the critical number for concavity. So it'll tell you where it switches from concave up to concave down. in that case. Because 0 ends up, I think if you actually graph this one, 0 is a vertical asymptote. Well, it's not a vertical asymptote, it's well, it is. It's just, it actually goes straight at that point.
Yeah.
So.
So
Yes.
that's the easy way to do it. Review answer.
No. I did it the easy way on the review answer too. Scott did it the hard way.
Yeah, it was like a page and a half.
Scott sends it to me. I'm like, yeah, I'm not doing it that way.
How to use rational root theorem and all. Yeah.
He got this massive polynomial that he had to simplify down to find out his critical numbers.
It was terrible.
Yeah.
Not doing it.
Hey, you learned what not to do, and you actually learned a lot of other stuff, rational root theorem and everything else. Like you know, so, it wasn't all for naught. All right, this one you're also going to do mins and maxes. Mix in. On the trig ones, and I didn't put it on here, but it will be on the actual test. You're only looking from 0 to 2 pi. Because technically trig goes on forever. So you're going to have a million maxes and mins. So
Oh wait, you don't know it on the test.
when I did the actual, when I did the actual solution guide, I didn't have the actual domain restriction on the actual test. I will on the actual test. So only do 0 to 2 pi, so this way you can actually find the mins and maxes. And actually, that's the problem with concavity, because this problem right here, concavity gets really, there's a ton, even between 0 and 2 pi. So that's why in my thing I actually said not doing the concavity. All right, so we just have to find y prime. So this one, remember, this one is the same thing as saying sine x to the third power. So we have to do the chain rule for this one. So I have 3 sine squared x, and then the derivative of sine x is cosine x. All right, so in this case, again, let's find our critical numbers. So it's wherever this equals 0. Since this is, the last couple ones we did were fractions, this one is multiplication. As long as any part of it is 0, the whole thing is 0. So the 3 doesn't really matter. So I'm just going to look at the sine x, because if it's squared, again, it's not going to change my critical number. So sine x is 0 when x is 0 and pi. Cosine x is 0 at pi over 2 and 3 pi over 2. So those are so I have 4 critical numbers in this situation. Remember the, well, actually I'll just graph it quickly because it's easier than doing it the other way. So sine goes like that, and cosine goes like that. So that's 0, that's pi over 2, and that's 3 pi over 2. So I have 4 critical numbers that I need to look at in this case. Again, all I'm caring about is if it's positive or negative, right? All right, so if we look at this, can sine squared x ever be negative? No, because it's squared. So that is always going to be positive. So the only thing I need to worry about is that. Okay? So I just need to know if cosine is positive or negative. Okay? So I've got my, And I'm going to put these in order. So from 0 to pi over 2, cosine is positive. From pi over 2 to pi, cosine is negative. From pi to 3 pi over 2, cosine is negative. And from 3 pi over 2 to 2 pi, cosine is positive. Everybody say how I got that. I used my wonderful crap like the so it starts off with positive, it switches at those points. So that's right there, 5 over 2. So in that part right there, cosine positive. It's not the direction it's going, it is where it physically is. So when I plug in numbers from 0 to pi over 2, I'm going to get a positive answer. And since this is my derivative, 2 positive is positive, so I know it's positive. From here to here, I'm plugging in, I'm going to get a negative number, so negative times positive gives you a negative. From pi to 3 pi over 2, cosine is still negative, so negative times positive is still negative. After 3 pi over 2, cosine becomes positive again, so positive and positive gives you a positive. So I have it's increasing to pi over 2 and then decreasing after it. So a max at x equals pi over 2. And then a min at 3 pi over 2. And there's nothing at pi because it doesn't change direction there. Does that make sense? So if it's, remember, the whole thing is you're looking at where it's going. So it's going up to that point and then down from it. And then down to that point and then up from it. Because remember, the derivative is telling you the slope of it. So if the slope is positive, that means it's going up. Slope is negative, it's going down. So if it's going up to something and then down from something, that's a max. Because at that point, at the critical number, so pi over 2, it's 0. So that means it's increasing to that point and then decreasing after that point for the slope. So, and that's why you look for each. Like in this case, there was 1, 2, 3, 4 critical numbers. So I had to find one in each section. And technically, there's another critical number, 2 pi over here. I just didn't write it. All right. Yes. Possibly. Actually, I'll show you. This graph looks crazy. And why I didn't keep going with it. So that's what your end of graph ends up being. So there's an inflection point in here. There's an inflection point in here. There's another inflection point here. which I think that is pi. So this way, because it changes from that direction to that direction, there's another inflection point here. There's a whole bunch of inflection points in this one. That's why I want you to go through and do that one. So yes, pi is an inflection point. So, and a lot of times that's what happens when you get ones that just doesn't change direction. It's like there's obviously something going on at that point because it is a critical number. It just goes to the second derivative and becomes that inflection point. All right. Next one. So this one will be concavity, mostly because there's no actual critical numbers for mins and maxes. So this is one that you could do this as the quotient rule, but you're going to have the derivative of 1, which comes out to be 0 anyway. So it's actually just as easy to make this, just move it up top and do this as a chain rule. Because you're going to have to do the chain rule anyway for this thing down the bottom because of the negative x. So I just changed this to this. And just did it as a chain rule. I don't think it actually really matters. I think you could technically do it as a quotient rule, and I think it would come out to be the same thing. I think I did the quotient rule in the second part of it. Yeah. So, so this one, the derivative of the inside. So the 1's going to disappear, and it's going to become negative e to the negative x. So that's the derivative of the inside. And then the outside, I have negative 1 plus e to the negative x to the negative second power. So simplifying this down, I get e to the negative x over 1 plus e to the negative x squared. Any questions on that before we do the second derivative? Because it's the derivative of e to the x is always what e to the x is. So that's never actually going to change. So if it was e to the x squared, it would still be e to the x squared. Because remember, when you're doing, because in essence you're doing the chain rule. You're doing the derivative of negative x, and that's where the negative 1 comes from, in the front, or the negative sign comes from. And then it's the derivative of e to the u, which is e to the u. So that stays. The nice thing about e's is no matter what you do, no matter what it is, that will always stay the same. Whatever's in front will be whatever the derivative of that piece is, which is where the negative sign came from. All right, for my second derivative, you have to do the quotient rule. There's no other way around it in this case. Yes, you could do the product rule, but that's not any easier in this case. So I have f of x is e to the negative x. So f prime of x is negative e to the negative x. G of x is 1 plus e to the negative x squared. G prime of x is negative e to the negative x two times, actually, I'm going to run out of room. So the derivative of the inside is exactly what I just did up here. So it's just negative e to the negative x. Then I have, bring down the 2, and it's 1 plus e to the negative x. So second derivative is negative e to the negative x times 1 plus e to the negative x squared minus e to the negative x times 2, or negative 2 e to the negative x 1 plus e to the negative x. All over 1 plus e to the negative x to the fourth. Okay. So we've got, I've got an 1 e to the negative x there, 1 e to the negative x there, and 1 e to the negative x there, right? I know I have 2 and 4, but I mean, I have at least 1 in every one of those spots, right? So since there's 1 in every single spot, I can cancel them out. So I'm now left with negative e, not in highlighter, negative e to the negative x times 1 plus e to the negative x plus 2e to the negative 2x all over 1 plus e to the negative x to the third. Really? I just want to make sure I was actually in the right spots. Yeah.
Yeah, you have.
Okay, that's right. All right, so I have negative e to the negative x plus, or minus, negative e to the negative 2x plus 2e to the negative 2x. Which comes out to be e to the negative 2x minus e to the negative x. That's not what I had.
I think you should go about it for long.
That's wrong. Where did I screw up here? Hold on. So we've got, I just want to make sure I actually did my part right. Fx is e to the negative x, that's right. Good. The derivative of that's that. Yes, that's there. I already messed that up. I'll figure that one out later.
So you're what's wrong?
It's not. This one I had an e to the negative 2x pulled out.
Yep.
Which means I have an e to the third x somewhere. And I don't know where I got the negative third x. Oh, right there. But I canceled that one out.
Yeah, you just move the order around.
No.
Or did I?
I forgot when I did this one. I forgot to cancel that. When I pulled it out of here, when I took that out and made that a 3, I forgot to cancel that one out. That's how I got the negative, the x to the third, which I shouldn't have had. All right. So, it's fine. I now have, so we can simplify this down. I have e to the negative 2x minus e to the negative x all over, what was it, 1 plus e to the negative x squared. And I'm going to pull out an e to the negative x here. Squared. All right. It's not actually going to change my answer, though. The answer was still right. Huh?
How did you get to a square?
There was a square right there.
It's not like you. Did you get another 1 plus e to the negative x? Oh.
Where? In this work here?
Right there. We have on the number. It's
Yep.
cube, and then it goes to square.
Oh, it is supposed to be cubed. Sorry. I copied it over and didn't.
Okay, that makes sense.
Sorry. All right. So we now have to figure out where it's going to be where it's going to the critical numbers. So let's find my critical numbers first. So can e to the x ever be 0?
E to the x.
No. As horizontal asymptote. As 0. So no matter what number I put in for x, it's just going to get closer and closer to 0. But never actually 0. So that will never be 0. Okay. So now I really just have the other two that I have to look at. So we have e to the negative x minus 1 equals 0. So e to the next x equals 1. So that would mean x equals 0. And then I have 1 plus e to the negative x equals 0. So e to the negative x equals negative 1, which can never happen. So that's my only critical number. Does that make sense? And then you could also, if you really wanted to write the other one, you could say this one equals 0. So that can't happen, and that can't happen. Yeah. And this is really why simplifying, this is why the algebra really is in this one, because you have to simplify it down. If you can't simplify it down, finding your critical numbers is going to be a nightmare. Because you really want to get it to multiplication and division.
How do you eliminate the last part, the 2 e's for negative 2x?
I didn't actually. I did -1 plus 2, which is 1.
So
Everybody's like, I'm getting a 90.
you put together e to the negative x and negative 2 to the negative x.
How did I put which one?
Why are they together?
These two?
Before. There.
I multiplied that times that. I distributed.
No, on the other.
This one?
Yeah. Something's just not making sense.
Okay, hold on. All right, so this part right here comes from this times this,
No, yes, I
that
get
times that,
I get that.
and then that.
No, yes, no, I mean before that. Like,
Oh, so I crossed off one.
the other side. What? 2 e minus 2 to the x. How did that happen?
That times this part right here came from that times that.
Yes.
So this right here was this. That's G prime. Because remember, the quotient rule is the derivative of f, which was that,
Yes.
times g,
Yes.
minus derivative of g, which is this, times f. Lots of e negatives, x's, yes. So it's this times that, which is that right there. So I said there was 90s, this one.
So the reason e to the negative x and negative 2 times e to the x comes together is because the negative 2 you can handle as a separate thing, right?
Yeah. So these are it's just multiplication. So e to the negative x, so negative times 1 times negative 2 is 2.
Yes.
E to the negative x times e to the negative x is e to the negative 2x. It's just like 2x times 1x is 2x squared.
Well, we just ignore that. We just take out the
This piece right here, I cancel.
No, yeah,
Oh.
I know you took them out and canceled.
I'm not ignoring the negative 2. That's where that 2 stayed, that's why the 2's still there. It's, okay. I now know where you're messing up, so hold on. If you had this, could I do that?
Yes.
To what?
2 times x 5.
Right. It's no different than,
No, but isn't 2 preemptively negative?
well, doesn't matter, I can make a negative. This and this are the same thing. conceptually the exact same thing. The first one looks nicer, but conceptually the exact same thing. I'm just adding the two exponents. Just like I'm adding those to get that. Negative x plus negative x is negative 2x.
Okay.
Okay, it doesn't, the coefficients don't matter. You just multiply the coefficients.
Okay, I don't know. Something just in my head.
That's okay. You're allowed. It doesn't, but I'm okay.
Well, to me, what?
It clicked.
Yes. It's
Okay.
Just, it's just my head didn't want to make it.
That's okay. All right, so we got our critical number. We still have to find if it's what's before and after. So just pick a number. Yes.
You say e negative x equals 1, then you also say e negative x equals 0.
Okay, there's 3 parts here that I have to test.
Yeah.
That's why we want to get it to multiplication division. Because multiplication division make it real easy for zeros. If there's a 0, it's a 0.
Yep.
So I tested the first part, e to the negative x equals 0. That never happens. That was that. That was yellow. That's that one. Never happens.
Gotcha.
Then I tested this one. That gives you 0.
Okay, you just flipped it. Gotcha. Yep.
And then I tested this one. The third doesn't matter because it's whatever's inside of it. That can never happen.
Yes. Yep.
So the only one that matters is the first one.
Gotcha.
So,
Makes sense.
all right. I'm going to erase this because I need the space. Well, I don't really need the space, but it's going to be easier to write. Now, just again, we're looking for if it's positive or negative. That's all I care about. Okay? All I care about. So if I chose x is negative 1, so e to the 1, that's positive, right? E to the 1 minus 1, so is e bigger than negative 1? Is e bigger than 1? Yes, right? Because e is 2.7 something, right? Okay, so I have positive, positive, and this is also going to be positive. So that's positive. Notice, I don't care what the number is. I literally only care if it's positive or negative. Okay? So the only one I had to do any little calculation was that one right there, and I just had to know that e was bigger than 1. All right, so if x is greater than 0, or no, sorry, less than 0. If x is less than 0, it's concave up. Because it's positive. Now let's pick the other side. X equals 1. So that's going to be positive. If x is negative, if e to the negative 1, that's 1 over e, correct? And that is less than 1. So that's going to be negative. And that's still going to be positive. So this is going to be negative. So when x is greater than 0, it's concave down. That's, again, why we need to get it to multiplication division. It makes it easier to find the critical numbers, and it makes it really easy to find positives and negatives. Yes? Because if it's 1 over e, it'd be 1 over 2.7 something, which is definitely less than 1. So that means the negative 1 is bigger than that number, so you're going to get a negative answer. And you could literally do it in decimals, like to actually plug the number in and get the answer. So you don't necessarily have to just do it mentally. You could type it in decimals and get an actual number answer. And that'll tell you if it's positive or negative. The goal, though, is to be able to figure it out, like, just looking for signs, because that's all you really need in this case. Wrong one. Okay. This will be minimax. So this one is product rule. So f of x equals x, f prime of x equals 1, g of x equals ln of x squared, g prime of x, we have to do the chain rule for this one. The ln of x is 1 over x times 2 ln of x. So y prime is 1 times ln of x squared equals 2 ln of x, oh, that equals, plus x times 2 ln of x over x. So I get ln of x squared plus 2 ln of x. Now remember what I said. You want things as, if you can get them into multiplication division, get them into multiplication division. So I'm going to pull out an ln of x. So I have ln of x plus 2. All right. Any questions with what we did up to there? That should be the same one I got. Oh, I did it
Yeah, you
different.
didn't pull out the ln.
I didn't pull the ln x.
Which is fine to use the U.
Yeah. I was looking at like, I was going to say what I did. I'm like, I don't remember doing that when I did it. Because that'd be the same answer though. I actually kind of like this way better.
Yeah, I just found that really useful using the ln x as U.
Yeah.
Yeah, I really like that.
So here, I'll show you this one real quick. So this I did in the actual thing. So it's basically works out to be a quadratic. And what you end up doing is exactly what I just did there anyway. It's like, it comes out to be the same. So there's just extra steps. Which is why I've been saying all along, it's like try to get things to multiplication division if you can. It makes your life easier. All right, so now we're going to set each piece equal to 0. So I have ln of x equals 0. So the only way to get rid of the ln, we have to do e. So this side is x, e to the 0, so x equals 1. And then I have ln of x equals 2. So I have x equals e to the second. Oh, sorry, not e to the second. Oh, I forgot, negative. So e to the negative second power, which is 1 over e to the second. So those are my two critical numbers. All right, so again, we're just looking if it's positive or negative. Now, this is where understanding what ln looks like, it would help. So if we're looking at ln does one of these numbers. that right there is 1. So between 0 and 1, ln of x is negative. When x is greater than 1, ln of x is positive. All right, so I've got, if you want to put my wonderful little number line here, I got 1, I got 1 over e squared, and after that point doesn't matter. So let's do the easy one. Let's plug in 2. So if I plug in 2, ln of x is positive, ln of x plus 2 is positive. So it's positive over here, right? I don't even know what 2 points are. I don't even, hold on. So that's approximately 0.13. All right. So I know it's positive past the 1. Let's plug in 1/2. If I plug in 1/2, the original ln of x is going to be negative, correct? Okay. Now, is that going to be bigger than 2? If I plug in ln of 1/2,
Negative 0.16.
it is not bigger than 2. So therefore, that's positive. So I add negative, positive, so that's going to be a negative. So it's positive, positive, so it's positive. And now over here, if I plugged in, well, technically over after this point here, so if I went over this side, I can't plug in 0. So let's plug in 0.1. So ln of 0.1, that's going to be negative. ln of 0.1, so it's going to be positive on that side. Does that make sense? Again, you could just plug the numbers into decimals and get the answer. All right, that's fine. So it's increasing to that point and decreasing after that point. So I have a max at x equals 1 over e squared. And then it's increasing after that. So I have a min at x equals 1. Yes. Any questions? All right. Remember, don't always use the L'Hopital's rule. Maybe you can simplify first. I'm not going to do that one. I will do this one. All right, so L'Hopital's rule only works on what? Fractions. So I need everything in a fraction. So I need to change this to a fraction. So I have sine of 5x, and remember cosecant 3x is the same thing as saying 1 over sine of 3x. So this is the same thing as saying sine of 5x over sine of 3x. And no, that does not equal sine of 2x. Always check if you can plug the number in first. Sine of 0 is always what? 0. So it doesn't matter what number is there, 5 times 0 is still 0. So I do have to do L'Hopital's rule on this one. So I've got f of x is sine of 5x. So f prime of x is 5 cosine of 5x. G x is sine of 3x. G prime of x is 3 cosine of 3x. The 5 in front and the 3 in front come from the chain rule. Because the derivative of 5x is 5. The derivative of 3x is 3. So in essence, you do have to do the chain rule for those. So now I'm going to do the limit as x goes to 0 of 5 cosine of 5x over 3 cosine 3x. Now what's cosine of 0? 1. So the top is 5 and the bottom is 3. And that's my answer. All right, I got time to do one more. Do you want 9 or do you want 10? 10? You can look whatever the other one up on the notes. It's there. Yeah. I put it up there, I think it was Monday. Whenever I sent to Scott. I think I did it Monday and put it up there. I can't remember if it was Monday or, well, actually today's Tuesday. All right. So find the points on the ellipse 4x squared plus y squared equals 4 that are farthest away from the point 1 minus or 1, 0. So when we're looking for distance from something, we're looking at the distance formula. So we're looking at the distance formula. The distance formula is x2 minus x1 squared plus y2 minus y1 squared. Probably. Yes, you're going to use that. I told you, the problems are going to be basically the same. So number 10 will be a distance formula problem. It might not be this one, but it will be a distance formula problem. So I basically need to figure out which all the pieces are in terms of x. So I've got, make x squared just x. We've got x1 is 1. We've got y squared, which I got to solve. So y squared, or y2 will be y, and y1 will be 0. So I have to solve this for y. So I can have everything in terms of x. So I got 4x squared plus y squared equals 4. So I got y squared equals 4 minus 4x squared. So y equals the square root of 4 minus 4x squared. Yeah. Which isn't going to matter in a second. So my d now becomes x minus 1 squared plus or minus square root of 4 minus 4x squared minus 0 squared. And if you remember right, when I did this problem in class, I said we could just use the d squared, so we're just looking at the stuff underneath it, which makes my life a little bit easier. So this becomes x minus 1 squared plus, now the 0 disappears, and squaring of that just gives you 4 minus 4x squared. That's why I said the plus or minus doesn't matter, because the square is going to get rid of it anyway. All right. So we've got our that, which I'm going to clean up a little bit to make my life easier. So we're going to have x squared minus 2x plus 1 plus 4 minus 4x squared. So I get negative 3x squared minus 2x plus 5. Find the derivative of that, so I get negative 6x minus 2. Now find my critical number. So negative 6x minus 2 equals 0. So x equals negative 1/3. Now, we're looking for the one that's farthest away, right? They're not going to ask you a question that's not going to work. So that's the farthest away. We don't have to worry about proving that it's a max. You're going to assume it's a max. So we can now plug it back in to find the y, because we need to find the actual point. So this one you do need to find the actual values. So y equals plus or minus the square root of 4 minus 4x squared. Now I'm going to plug in my negative 1/3 to that. So I've got y equals 4 minus 4/9. So I've got the square root of 32/9, which is 4 square root of 2 over 3. So my 2 points are negative 1/3 4 square root of 2 over 3, and negative 1/3 negative 4 square root of 2 over 3. That's where the plus or minus comes into play. If you left it as the square root of 32 over 9, I probably would just take off a point for not simplifying. But out of all the simplification, that's probably the easiest one. There was a lot of other stuff we had to clean up with this problem. Remember, because it's an ellipse, there could be multiple points. And this one actually, if you think about this, so if we're looking at orbits are all ellipses. So depending on what is at 1, 0, this is looking at the farthest point away from an orbital path. So, and if anybody happens to be up at 1 o'clock this morning, Artemis is supposed to launch. Unless the onion was correct and Artemis is scared to launch, in which case it's just not going to go anywhere. Yeah, the onion put out, it was hilarious. It goes, Artemis has announced that it is refusing to launch to the moon because it's really far up and it's scared of heights. It was really funny. All right.